Swayam Prabha, free DTH channel for education.
Now J0 dash of x, okay, so we have used this property to prove that. So we'll prove that J0 dash of x equal to minus J1 of x. Let us prove that. Okay, let us prove this property. So what is J0 dash of x? Let's erase, let's start things. Okay, so J0 dash of x, prove that J0 dash of x equal to minus J1 of x equal to prove it. So what is J0 dash? So let us prove that. Solution J0 of x is equal to x by 2 power nu is going to be there, but nu is 0, therefore that is not going to be there. Summation k equal to 0 to infinity. Okay, this is going to become like minus 1 power k divided by k factorial into k plus n plus k factorial will come. So n is 0 here, therefore this is also k factorial is going to come into x by 2 whole power 2k is going to come. Okay, I will write this as x power 2k into 2 power. I am going to write this as x by 2 x power 2k divided by 2 power 2k, because once I am doing the differentiation, maybe I will forget that to put that 2k over there. Therefore, I am going to write that. So J0 dash of x is going to become like summation k equal to 1 to infinity. Okay, minus 1 power k factorial into k factorial. Okay, I'm going to use that k factorial into k factorial into 2k into x power 2k minus 1 divided by 2 power 2k. Okay, so I can write this as k gets cancelled, therefore this is going to become like k minus 1 factorial, and this k is cancelled, and this 2 I am going to cancel, therefore this is going to become like 2k minus 1. Okay, therefore this I can write as summation k equal to 1 to infinity minus 1 power k divided by k factorial into k minus 1 factorial into x by 2 power 2k minus 1. Now what is J1 of x? J1 of x is nothing but, okay, J1 of x is nothing but summation k equal to 0 to infinity, that is x by 2 is going to be there. I'm going to put it inside that, minus 1 power k divided by k factorial into k plus 1 factorial is going to come, okay, into x by 2 power 2k plus 1 is going to come. Okay, this is my J1 term. Now here I have almost similar term, okay, k equal to 1 it is starting. So if it is k equal to 1 is starting, then what you have to do, push k equal to, wherever k is there, replace that with k plus 1. Wherever k is there, replace with k plus 1 and then see whether you are going to get the answer or not. Okay, so in that case what I am going to do, I am going to write this, wherever k is there I am going to replace that, summation k equal to 0 to infinity minus 1 power k plus 1 divided by k plus 1 factorial into k factorial into x by 2 power 2k, so 2k plus 2 minus 1. Okay, therefore this is going to become like 2k plus 2 minus 1 is going to become like 2 power k plus 1 is going to come. Okay, 2 power k plus 1 is going to come. So there is only one difference is there. Here minus 1 power k is there, here minus 1 power k plus 1 is there. Therefore I can replace this one as minus k. Okay, I can put minus symbol over here. Therefore this is going to become like minus j1 of x. That's all. Okay, so now another problem. Now what I'm going to take this one. J of x is going to be, okay, J of x is nothing but square root of 2 pi into x into sin x. Okay, so before that let us see what is the sin x series. Okay, sin x series is this one. Sin x is, I can write it as my summation k equal to 0 to infinity minus 1 power k plus 1 minus 1 power k x power 2k plus 1, okay, x power 2k plus 1 divided by 2k plus 1 whole factorial. This is from the Taylor series expansion, you can get that. Okay, this is the sin x series. Now we are going to use that. Okay, we are going to use this one as we are going to derive this one. Okay, so if I j alpha of x, so j alpha of x is nothing but I can write this as x by 2 power half, okay, summation k equal to 0 to infinity minus 1 power k divided by k factorial into gamma of half plus k plus 1, okay, half plus k plus 1 into x by 2 power 2k. Okay, this is nothing but my 2k plus 2k. Yeah, fine. So you can see that I can take some. You compare these two, and then we are going to obtain that. What we are going to do is that we are going to obtain this one. So we need to multiply and divide by something, and then we get that. Okay, so we'll try to do that. So j naught dash of x, we are going to get it. So whatever we have here, so we are going to get that. So this is going to be 3 by 2, etc. Now what I'm going to do, this one, okay, I'm going to write this as x by 2 into 1 by 2. I can write it as 1 minus 1 by 2. Okay, summation k equal to 0 to infinity minus 1 power k divided by k factorial into gamma of k plus 3 by 2 into x by 2 power 2k is going to be there. Okay, so this one I can write it as 2 by root x. Sorry. So x power minus 1 by 2 I can write it as 2 by x square root of 2 by x summation k equal to 0 to infinity. I can put this x1 x by 2 inside. So this is going to become like minus 1 power k factorial into gamma of k plus 3 by 2 into x by 2 power 2k plus 1 is that. Okay, so almost we got this one. Okay, what we got? We got 2 by x is there. Okay, I got 2 by x is here. Almost I am going to get that. Okay, so I have 2 by x here. So 2 by x is here. 2 is here. 2 by x is here. 2 by x is 2 by x is here. I have only one term, root pi is remaining. Okay, and I have sin x. I got to compare. Summation k equal to 0 to infinity is there. Summation k equal to 0 to infinity is there. Minus 1 power k is there. Minus 1 power k is there. X by 2 power x into 2 power 2k plus 1 is there. That is also there. So remaining term. So what I need to prove is that remaining thing I got to prove that. So remaining thing. So you can compare that. What remains is that we got to prove that k factorial into gamma of k plus 3 by 2 into 2 power 2k plus 1, okay, equal to, you got to prove that 2k plus 1 factorial into root pi. If you prove that, this is going to be done. Okay, if I just suppose I prove this one, then you can replace this one as, okay, you can write this one as root 2 pi x into summation k equal to 0 to infinity minus 1 power k divided by this. I am going to replace gamma of k factorial gamma of k plus 3 by 2 into 2 power 2k plus 1 as 2k plus 1 factorial into root pi. I am going to write root pi I have already taken out. Therefore, this is going to become like x power 2k plus 1 is there, x power 2k plus 1. So this I can write as then square root of 2 pi x into sin x is going to come. So we are remaining to prove only k factorial into gamma of k plus 3 by 2 equal to 2k plus 1 factorial into root pi. That is the only thing we need to prove. So that is also we are going to prove it now. So we know that gamma of n plus half is nothing but 2n minus 1 factorial into 2 power 2n minus 1 into n minus 1 factorial into pi is there. Okay. Therefore, what I can do, I can just replace that wherever gamma of n plus 2 n plus half is there, where I can replace that. Okay, I can replace gamma of k plus half is going to become like 2k plus 1 factorial. Okay, 2k plus 1 factorial into 2 power 2k plus 1. Okay, so this is going to become like gamma of k plus 3 by 2 is going to become like 2k plus 1 factorial divided by 2 power 2k plus 1 into k factorial into root pi is going to come. So that is already following. So this is the what we want to prove, that is following simply because of gamma of n plus half definition. Okay, from that definition you can prove that. So therefore this is going to be obtained. That's all. Okay, there is nothing much more to prove. So now we are going to see some more problems on Legendre functions. Okay, Legendre function we are going to see. Legendre functions of first kind. Okay, what is the Legendre functions of first kind also we are going to prove. And Okay, Legendre functions are first kind also we are going to. So Legendre functions are first kind. So P naught of x, P1 of x, P2 of x we have seen. So we know that P naught of x is constant. Therefore, you can see that P naught of x equal to 1, which is there on the top. P1 of x is x. Okay, so that is also there. And P2 of x is going to be parabola. So that is there in the blue color. And P3 of x is going to be the hyperbola. Sorry, the cubic is going to come. That is also there. Similarly, you can get P4, P5, etc. Okay. Similarly, Bessel functions of Legendre functions of second kind is also there. Q0, Q1, Q2, etc. So that is also given here. Q0, Q1, Q2 is also there. Now we are going to prove one more. Pn of x equal to d power n by dx power n 1 by 2 power n into n factorial into 1 by 2 power n into n factorial into p power n by dx power n into x square minus 1 power n. So this part we have to claim. Okay, let us claim that. So that means what I have to prove is that I have to prove that Pn of x is going to satisfy the Legendre polynomial. So you have to prove that if I substitute in that equation, okay, I have that Legendre equation is there, right? So if I substitute it in that equation, it should satisfy that. Okay, that is one way. So it satisfies the Legendre equation. We have to prove that. Okay, let us prove this one. So first I'm going to simplify this. I'm going to take what is the expression is going on. Let me take x square minus 1 power n. Okay, then what is z dash? Z dash is going to be x square minus 1 into n minus 1 into 2x into n is going to come. Okay, so therefore I can write x z dash, not x z dash. I can write x square minus 1 into z dash. Okay, so this is going to become like 2nx into x square minus 1 power n. Therefore, this is going to become like 2nx into z. Therefore, I can write this as 1 minus x square z dash plus 2nxz equal to 0. Okay, keep this, remember. Now I'm going to take one more thing. Okay, one more thing I'm going to take. Suppose u is equal to 1 minus x square. Okay, I'm going to take u is equal to 1 minus x square is there. Then what is u dash? U dash is minus 2x. What is u double dash? U double dash is minus 2. What is u triple dash onwards? Okay, u3 onwards, it is going to become 0. Okay, so I can write uk equal to 0 for all k greater than 2. Okay, so that I can write. Now what I am going to do, I am going to use the Leibniz rule. Okay, so you know this formula, u v dash equal to u dash v plus u v dash. Now what is u v? Okay, u v of mth derivative. That is going to be summation. I can write it as summation k equal to 0 to m mck. Okay, u power u kth derivative, kth derivative of u, and then vth derivative of m minus k. This is the Leibniz formula which we are going to use it now. Okay, so now what I am going to do is that, so since this is 1 minus x square into z dash is there, what I am going to use is that I am going to use this property over here. So what I am going to do right now is I am going to find what is this one. This one I can write it as, okay, this one I am going to write it as u into z dash I can write, okay, because u equal to 1 minus x square plus 2n x z equal to 0 I can write it. Okay, now what I am going to, okay, so we are going to find this one. I am going to take the mth derivative of this one. So this is going to become like d power m by dx power m into u z dash. Okay, first I am going to find this one. Okay, that is going to become like summation k equal to 0 to m mck u power k z power m minus k plus 1. Okay, that is going to come. Now I can write this as u power k equal to 0. Therefore, u is going to come. This is going to become like z power m plus 1 is going to come. This is going to become like u dash is going to come. mck is there. Therefore, there is a m is going to come. M into u dash is going to come. And this is going to become like z power m. And this is going to become like m into mc2. Therefore, m into m minus 1 by 2. Okay, m into m minus 1 by 2 into u double dash into z power m minus 1 is going to come. Okay, remaining term all going to become 0 because u3 onwards it is 0. u3 into something is going to come, u4 is going to come. Those are all 0 because of this one. Okay, so therefore I'm going to ignore that. So the remaining thing I'm going to replace 1 minus x square into z power m plus 1, okay, plus m into u dash is minus 2x. Therefore this is going to become like minus 2 mx u z power m, okay, plus m into m minus 1 by 2 into minus 2 is that. Therefore minus 2 gets cancelled. Therefore this is going to become like m into m minus 1 into z power m minus 1 is going to come. Okay, now I'm going to do the same thing for here. Okay, d by d power m by dxm of 2nx z I'm going to find. So that is going to become like, okay, 2nx z, that is going to become like as follows. So this is going to be I'm going to take this as u and this as v. Okay, so for the same thing I can do. So u into z power m, therefore that is going to become like 2nx into z power m. Okay, z power m, you are using this one. Okay, you are using this property. Okay, plus 2n into, okay, I am taking the first derivative, so 2n into z power m minus 1 is going to come. Next term it is going to 0, therefore I am not going to worry about it. Only these two terms are going to exist. Okay, 2n into m into z power m minus 1. Because MC1 is there, therefore m will come. So that's all. Now you sum these two together. Okay, if you sum these two together, what I am going to get? I am going to get, okay, so if I just sum this together, I am going to get this as, okay, this is going to become like equal to 1 minus x square into z power m plus 1 minus 2 mx z power m, okay, or I can write this as minus 2 mx is there, okay, so here 2 mx and here 2 nx, so I can write this one as 2n, okay, summing it up, so 2n minus 2m into x into z power m, okay, and this two term I can write it as 2 m, I can take it out, okay, m if I take it out, suppose if I take m out, and this is going to become like 2n, and this is going to become like minus m minus 1 into z power m minus 1 is going to come. Okay, so that is, if I take the, this is already 0, therefore if I take the mth derivative, that is also going to become 0. Okay, so this is going to become 0 because of this is already 0. If I take the mth derivative, it is going to become 0. Now I am going to replace m equal to, wherever m is there, I replace m equal to n plus 1. Therefore this is going to become like 1 minus x square z power n plus 2, okay, plus 2 into n into minus 2 m plus 2 minus 2m minus 2, okay, minus 2m minus 2, okay, or minus 2n minus 2, sorry, minus 2n minus 2, because m equal to n plus 1 I am replacing, minus 2n minus 2 into x into z power n plus 1 plus n plus 1 into, okay, 2 into n into m equal to n plus 1, therefore that is going to become like n is going to come, okay, 2n minus n into z power m minus 1 equal to 0 is going to come. Okay, that's what I have written here. So that is going to become like, this is going to become like 1 minus x square into z power n plus 2 plus this is going to become like 2n cancel, therefore this is going to become like minus 2x minus 2x into z power n plus 1. Okay, so here already I got replaced by n plus 1, therefore this is going to become like n, okay, z power n, and this is going to become like plus n into n plus 1 into z power n is going to come. Now you can see that you replace wherever n plus 2 is there, okay, you replace y equal to z power n. If I replace y equal to z power n, then y dash is going to become like means z power nth derivative, y dash is going to become like z power n plus 1 is going to come, y double dash is going to become like z power n plus 2 is going to come. Okay, so therefore if I take y equal to z power n, this is going to become like 1 minus x square into y dash double dash minus 2x into y dash plus n into n plus 1 into y equal to 0. Therefore what I prove, suppose it's at y equal to z power n, okay, so what I have proved is that in that case I have proved that y is a solution of the Legendre equation, okay, so you are going to get this one, okay, therefore you got this one. So y equal to if I take this one, okay, z equal to x square minus 1, I have taken y equal to z power n. If I take it, then I can prove that, okay, so z is already x power n, x square minus 1. So this is going to become like z power n plus, this is going to become like x square minus 1 power n, nth derivative. Therefore, this is going to be there. Okay, therefore, this is going to be satisfying. This z power n is nothing but this one, and that is going to be this one. Okay, Pn of x. Okay, Pn of x with some constant is going to be there. That constant I am not keeping, so that's the only thing we need to remember. Only thing, this 2 power n into n factorial only I got to do that. So now what I have, y equal to, y is a Legendre polynomial. Therefore, what I am going to have is that I am going to have Pn of x. Okay, so Pn of x is going to become like, so y is so what I have proved is that y equal to z power n means y equal to d power n by tx power n into x square minus 1 power n, because my z is x square minus 1 power n. So this part I have proved. So this is a solution of this one. Therefore, your Pn of x is going to be, okay, of this form. Pn of x is going to be something c into d power n into t xn into x square minus 1 power n is going to be there. Okay, that is nothing but the Legendre polynomial, okay, which we are going to get. Now what we need to prove is that we need to find this c. Okay, so this is going to be a solution. We need to find your c such that Pn of 1 equal to 1. You got to find your c such that Pn of 1 equal to 1, because that is one of the properties of Legendre polynomial that we need to use it, and then we got to derive our c. Okay, so now what I have z equal to x square minus 1 power n. So this one I can write it as x minus 1 power n into x plus 1 power n. Okay, so now if I take the nth derivative z power n, okay, what I am going to have is that I am going to have two things. Okay, I am going to have, once again I am going to use the Leibniz rule. What I am going to have, I can write this as uv. Okay, I can write it as uv, and what you are going to get, u equal to x minus 1 power n. This I am going to call it as u. Okay, the first term I am going to call it as u. This is u, and this is v I am going to take. So in that case, once again, you can use that u power m etc. You can use that, and then what you are going to get, the answers for that, and for that I are going to apply the values at that place. So therefore, this is going to become like, okay, to x minus 1 power n etc. is going to come. What you are going to use, again you are going to use the Leibniz rule. So that is, therefore it is going to become like uv power n plus nc1 into uv u dash into v power n minus 1 etc. is going to come. Okay, now if you see this one, okay, now at x equal to 1 I got a value. Okay, at x equal to 1 I got a value. So if I put u of x, whenever u is there, okay, whenever u dash is there, what you are going to get is that you are going to get at Pn of 1, this is going to become 0. Okay, everywhere this is going to become 0. U is going to become 0 everywhere except the last term, it is going to survive. So that means what is it going to come? This u is going to be, u at 1 is 0, u dash at 1 is 0, u triple dash at 1 is 0, etc. So if you take u nth derivative, okay, u nth derivative, that is going to become like everything is going to vanish, only x is going to be there, so only that is going to survive, only un is going to survive, remaining all is going to become 0. Okay, so here what is it going to come? U of 1 is 1 minus x minus 1 power n, therefore this is going to become 0. Here it is going to become like n into x minus 1 power n minus 1, so that is going to become 0. Here u double dash, it is going to become like n into n minus 1 into x minus 1 power n minus 2 is going to become, so u dash bit of n is going to become 0 once again. Okay, this is going to become 0, this is going to become 0. So u n of 1, you are keep on decreasing, therefore you are going to get n factorial into x is going to come, so only this is going to serve. Okay, only u n factorial is going to serve. Now, so I don't need to calculate everything. So I just calculate only u power n into v, because I got to evaluate at n equal to x equal to 1. So I just calculate only this one. So un into v is going to become like then. Okay, what is it going to become? Un into v. Okay, un into v is going to come, which is nothing but z power n. Okay, so this is going to survive at z of 1. So therefore this is going to become like z n of 1 is going to become like un of 1 into v of 1. But what is v? V is nothing but x plus 1 power n. Therefore this is going to become like n factorial into 2 power n is going to come. Okay, therefore Pn of 1 equal to Pn of 1 I got to choose it equal to 1. Therefore what I have, c into dn into dx power n I have chosen. Therefore if Pn of 1 equal to 1, which implies okay, c into d power n dx power n into x square minus 1 power n equal to n point x equal to 1 I got your value. Okay, this is the one at x equal to 1 I got your value. Therefore this is going to become like c into 2 power n into n factorial equal to 1, which implies c is equal to 1 by 2 power n into n factorial. Okay, therefore what you are going to get? You are going to get your Pn of x equal to 1 by 2 power n into n factorial into d power n nth derivative, okay, x square minus 1 whole power n. Okay, this is going to be. So you can see that, okay, only this is going to come. Okay, one more problem. So two more problems are there. We'll solve it. Okay, what are those? So what I have is that I have this Pn of x we have defined. Now suppose n equal to 0 case. Okay, we are going to solve the Legendre equation for n equal to 0 and n equal to 1. So in that case, what I am going to have, y1 of x is going to become like, okay, y1 of x is going to become like 1, okay, 1 minus n into n plus 1 into n plus 1 by 2 into x square plus n minus 2 into, okay, n minus 2 into n into n plus 1 into n plus 2 divided by 4 factorial into x power 4, etc. is going to come. This is our y1 of x. Similarly, y2 of x we have written. Okay, y2 of x is nothing but x minus, okay, x minus n minus 1 into n plus 2 into, okay, divided by n minus 1 into n plus 2 divided by 3 factorial into x cube plus I have n minus 3 into n minus 1 into n plus 2 into, okay, n plus 4 into x power 5 divided by 5 factorial, etc. is going to come. Now when n equal to 0, okay, what is it going to come? y1 of x is going to become like, when n equal to 0, this is going to vanish, this is going to vanish. So everywhere n is going to be there, therefore this is going to become 1. That is nothing but p naught of x. Okay, when n equal to 0, y2 is going to become like, this is going to become like x minus 1 plus 2 divided by 3 factorial into x cube plus minus 3 minus 1 plus 2 plus 4 divided by 5 factorial into x power 5 plus etc. is going to come. So you can observe that this is going to be x, 2 and 3 is going to get cancelled, therefore you are going to get x cube by 3, okay, actually plus x cube by 3, okay, and this is going to become like minus minus plus is going to come, so therefore this is going to become like x power 5 by 3, 1 2 3 is there, only 5 is not there, therefore this is going to become like x power 5 by 5. Okay, similarly you can observe that next term x power 7 by 7 is going to come, etc. is going to come, therefore it is going to become like x power 2n plus 1 by 2n plus 1 is going to come, etc. is going to come. Okay, now what we are going to do, what is this equation we are going to see. For that we need to know what is ln x. Okay, ln x is ln of 1 plus x series. Okay, ln of 1 plus x series, what is that? Okay, ln of 1 plus x, using the Taylor series expansion you can find that. So using the Taylor series expansion, if you find, this is nothing but x minus x square by 2 plus x cube by 3, okay, plus x power 5 minus x power 4 by 4 plus x power 5 by 5 minus x power 6 by 6, etc. is going to come. Okay, so in general you can write minus 1 power, etc. is going to come. Similarly, I can find ln of 1 minus x. Okay, that is going to become like x, wherever minus is there. Okay, there you go to wherever x is there, that it is going to become like minus x. So minus x square by 2 minus x cube by 3 minus x power 4 by 4 minus x power 5 by 5 minus x power 6 by 6, etc. is going to come. Okay, now if you add these two terms together, okay, if I just if I subtract these two terms together, if I subtract these two, that I am going to get ln of 1 plus x divided by 1 minus x. Okay, if I subtract, this is going to become like 2 into x into, so if I subtract this, these two gets cancelled, these two gets cancelled, these two gets cancelled, all odd even powers gets cancelled, and remaining time I am going to get 2x plus 2x cube by 3 plus 2x power 5 by 5 plus 2x power 7 by 7, etc. is going to come. So I can take 2 out, therefore this is going to become like 2, everything is going to go over. I can bring that 2 over here, therefore this is going to become like 1 by 2 into ln 1 plus x into 1 divided by 1 minus x. So you can see that this is the same thing as this one, therefore this one I can write as 1 by 2 into ln of 1 plus x divided by 1 minus x. Okay. Now on the other hand, let's take case n equal to 1. Okay, this is another tutorial problem. So if n equal to 1, what I'm going to have is that I'm going to have y2 of x is going to become like, okay, y2 of x is going to become like 0 by x, because y2 of x is going to become like, if n equal to 1, y2 of x is going to become like, x is going to be there, n equal to 1, so this is 0, n equal to 1, this is 0, everything is going to 0. So this is called p1 of x. Okay, so it is not necessary that always y1 is going to be a polynomial. When n is 0, when n is odd, okay, when n is odd, you are going to get this one as a polynomial. When n is even, you are going to get this one as a polynomial. Okay, sorry, when n is odd, you are going to get this y2 as a polynomial. When n is even, you are going to get y1 as a polynomial. For example, you can see that n equal to 2, that is going to become like you are going to get a polynomial, because after this it is going to vanish. Similarly, here when n equal to 3, after this it is going to vanish. Okay, so when n equal to 1, what we are going to get? We are going to exceed p1 of x. So what I am going to say is that if n equal to 0, y1 is a polynomial, y2 is a series. If n equal to 1, y2 is a polynomial, y1 is going to become series. Now we will find what is y1. So y1 is going to become like, when n equal to 1, this is going to become like 1 into 2. Okay, 1 into 2 divided by 2 factorial. So 1 minus 1 into 2 by 2 factorial. So let's erase this one. Okay, so y1 is going to become like 1 minus 1 into 2 by 2 factorial, okay, 2 factorial here, x square plus minus 1 into, okay, 1 into 2 into 3 divided by 4 factorial into x power 4 plus etc. is going to come. So this I can write as 1 minus x square by x square, just x square, okay, 1 minus x square plus x power 4 by 3, then next term it is going to become like x power 6 by 5, etc. is going to come. Okay, so in this one, once again I can take x out. So if I take x out, this is going to become like x into x plus x cube by 3 plus x power 5 by 5 plus x power 7 by 7, etc. is going to come. So therefore I can replace this as 1 minus x into, this one I know already, what is x plus x cube by 3, etc. This I can write as x by 2 into ln of 1 plus x divided by 1 minus x is going to come. Okay, so that's what we have for this one. Okay, now last one, what we are, orthogonality property of the Legendre equation. Okay, so orthogonality means what we will see that in the next few slides, next lecture or sometimes. Okay, because we are going to see the Fourier series, etc. In Fourier series, once again, you have to use the trigonometric system where you will do the orthogonality, etc. and Sturm-Liouville problem, etc. is there. So at that time, we'll see what is the orthogonality, but we'll try to prove only this one. Minus 1 to 1, Pn into Pm of x dx is going to be 0 if n is not equal to m, and 2 by 2n plus 1 if n equal to m. So it is not only orthogonality property, it's called orthonormality property. You can take it, okay? So you can just multiply by 2n plus 1 by 2, then this is going to become like. So we know that Legendre equation can be written as 1 minus x square into y dash whole dash, okay, plus n into n plus 1 into y equal to 0. Now Pn is satisfying this one, therefore it is going to come like 1 minus x square into Pn dash of dash plus n into n plus 1 into Pn is going to be there equal to 0. Similarly, Pm is going to satisfy that. Another one is going to be 1 minus x square into Pm dash into dash plus n m into m plus 1 into Pm equal to 0 is going to be there. Okay. So now what I have, I'm going to use this 2 to when m is not equal to n, okay, I'm going to find what is that value. When m is not equal to n, I'm going to find that. Okay, so in this case, I'm going to satisfy. So P is going to satisfy this one, Pm is going to satisfy this one. Okay, so I'm going to find what is Pn into Pm dash is going to come. Okay, so I'm going to multiply. I'm going to multiply and first one by Pm and second one by Pn. Okay, so I'm going to multiply the first one this by Pm and this by Pn. Okay, and then subtract it. What you are going to get? Okay, so you are going to get it something like Pm into 1 minus x square Pn dash the whole dash. Okay, minus Pm into Pn into 1 minus x square into Pm dash the whole dash. Okay, plus I'm multiplying this one, so n into n plus 1 into Pn Tm. Okay, minus m into m plus 1 into Pn Pm equal to 0. Okay, so now what I have, I'm just going to integrate this one. So if I integrate with respect to minus 1, therefore this is going to become like minus 1 to 1. This is going to become like minus 1 to 1. This is going to become like minus 1 to 1. This is going to become like minus 1 to 1. Okay, now if I just integrate this one, this is going to become like 1 minus x square. So this I can write dx. Okay, dx is there. So this one I can write it as Pm into d of 1 minus x square Pn dash. Okay, I can write it. Okay, d of 1 minus x square into Pn, I can write it. Okay, similarly I can write the second one same way. Okay, minus Pm into, okay, this is integral, minus Pn into, okay, d of 1 minus x square into Pm. So Pm dash is that, Pm dash is, okay, Pm dash is going to be there. Plus this one I can write it as n into n plus 1 into minus m into m plus 1 into minus 1 to 1 Pn Pm equal to 0. Okay, now if you find this one Pm dash, okay, so this is going to become like UV rule, you can use that. So this is going to become like, I can use Pm into 1 minus x square Pn dash, okay, minus VDU is going to become like 1 minus x square Pn dash into Pm dash, okay, minus this is going to become like Pn into 1 minus x square into Pm dash. Okay, so I got to put minus 1 to 1 here. Okay, minus 1 to 1, plus there is a minus, so VDU term is going to come, that is going to become like plus 1 minus x square Pm dash into Pn dash. Okay, minus 1 to 1, plus this is as it is. Okay, n square minus m etc. is going to come, so that I can just simplify. This is going to become like n minus m into n plus m plus 1 into integral minus 1 to 1 Pn Pm is going to come equal to 0. Now you can see that when I substitute 1, this is going to become 0, minus 1, this is going to become 0. Similarly, if I substitute 1, this is going to become 0, minus 1, this is going to become 0. These two are same, therefore this I am going to cancel it. So what I am left with is that I am left with n minus m into n plus m plus 1 into minus 1 to 1 Pn into Pm into Pn into Pm equal to 0. Okay, so therefore n is not equal to m, therefore I can cancel this, therefore minus 1 to 1 Pn into Pm is going to become 0. Okay, so that's what I have here. That's what I have here. Now m equal to n. Suppose m equal to n, then what I am going to get? I am going to use that already we have proved one property. So using that property, we are going to prove that for m equal to n. Okay, that we are going to prove. Let us see what is going to come. So in that one we have used this one. Okay, z equal to x square minus 1 power n. We have used same thing. We are going to use it over here. So I am going to find what is integral. What is integral minus 1 to n 1 to 1 Pn square x dx. Okay, so that I can write it as Pn of x, I can write as 1 by 2 power n into n factorial whole square into minus 1 to 1 t power dn of z by dx power n, dn of z by dx power n into dx. Okay, where z is nothing but x square minus 1 power n. Okay, so once again I can use that. What I can do is that I can use the UDP formula. Okay, so if I use this one, so this is as it is. If I use the UDP formula, this is going to become like minus 1 power 1. Okay, so this is going to become like, I can write this as dn of z by dx power n into d of dn minus 1 of z dx power n minus 1. I can write it. Okay, so this is going to be u, this is going to be v. So therefore this I can write it as dn power z by dx power n into d power n minus 1 into dx power n minus 1. Okay, minus integral, this is going to become like dn plus 1 into dx power n plus 1. Okay, because v du I got to apply dn minus 1 dx power n minus 1 is going to come. Okay, so here z is there. Okay, so you keep on, so this is from minus 1 to 1. Okay, minus 1 to 1. So you can see that when dn minus 1 is there is at least one x minus 1 term is going to be survived. Okay, only at least one x minus 1 is going to be survived. So in that case, what you are going to get at minus 1 also it is going to become 0 and 1 also it is going to become 0. Okay, so at least one x square minus 1 term is going to be there. Okay, x square minus 1 power. If you are taking n minus 1th derivative, okay, you are going to have at least one x square minus 1 term is going to be there. Okay, at least one x square minus 1 term is going to be there. Therefore, this is going to become 0. So you keep on doing this. Okay, so if again you do this one, okay, this is this I can write as minus d n plus 1 into z by dx power n plus 1 d of d n minus 2 z by dxn minus 2. Okay, so once again I can replace that as minus. Okay, this one will become like d n plus 1 by d here x power n plus 1 x power n plus 1 into d n minus 2 z by dx power n minus 2. Okay, minus 1 to 1 and plus this is going to become like integral minus 1 to 1 d n plus 2 dx power n plus 2 d n minus 2 dx power n minus 2. So you keep on decreasing. Okay, after certain stage what you are going to get is that you are going to get everything is going to become like 0 here. So the boundary term is going to become 0. So this n is going to keep on adding over here. So after many steps, what you are going to get is that you are going to get this equation is going to become like whatever you have here. That is going to become like minus 1 power n d power 2n of z by d x power 2n into dx is going to come integral minus 1 to 1. That is going to come. Okay. Now what is d power 2n into x square minus 1 power n into dx power 2n? That is going to be 2n factorial. Okay, that is going to become like 2n factorial. So this integral is going to become like 2n factorial because you are going to take. So if I take this one x square minus 1 power n, if I expand this one, okay, x square minus 1 power n. If I expand this one, this is going to become like x power 2n. Then I have x power 2n minus 2, etc. is going to come. Okay, so if I take the nth derivative, if I take n derivatives over here, 2n derivative over here, so this is going to become like 2n into x power 2n minus 1. The next step it will become like 2n into 2n minus 1 into x power 2n minus 2 is going to come. Like this keep on decreasing. After you take the 2nth derivative, okay, 2nth derivative, z power 2nth if you are taking, then this is going to become like 2n factorial is going to survive. Remaining are going to become 0. Okay, so therefore this is going to become like minus 1 to 1 pn square dx is going to become like 1 by 2 power n into n factorial whole square into 2n factorial is going to be there. Okay, into I am going to have one more term. Okay, last term it is going to become like if I just keep on decreasing this last term z power 0 is going to come. Therefore there is a z here. Okay, that is going to be there. So this is going to become like integral minus 1 power n z dx is going to be there. Okay, but what is z? Z is nothing but x square minus 1 power n. Therefore I am going to write this as x square minus 1 power n dx. Okay, now what is the value of this one that we need to find? Okay, what is the value of this one? This is an even function, x square minus 1 power n. It's an even function. So minus 1 to 1 I can write it as 2 times 0 to 1 I can write it. Okay, so minus 1 power n, this I am going to write this as 1 minus x square power n into I'm going to write this as, okay, minus 1 I'm going to put it over here. Therefore this is going to become like 1 minus x square power n into dx is going to come. Now put x equal to sine theta, x equal to cos theta. Okay, put x equal to cos theta. Then dx is going to become like sine theta. Okay, and 1 minus x square is going to become like sine theta. Therefore, this I can write it as integral. Okay, the remaining thing as it is. Okay, the remaining thing terms are as it is. So into 0 to 1 or pi by 2, it will become like pi by 2 because x equal to 0 means cos 0 is going to become like okay, this is going to be dx is going to be minus and theta is going to come. Therefore, minus and the integral is going to interchange. So here, when x equal to 0, you are going to get pi by 2, and x equal to when x equal to 1, you are going to get theta equal to 0 is going to come. So you can interchange that variable. So you are going to get 0 to pi by 2 sine n plus 1 theta is going to come. Sine n plus 1 theta d theta is going to come. Okay, so now for this one you can find the answer. So sine 2n actually, because we have sine square theta, so sine square 2n. Okay, sine 2n plus 1 theta is going to come into d theta is going to come. Now you can do that. Okay, reduction formula. Using the reduction formula, you can find the answer. So for this, the answer is that you have 2 power n into n factorial square. Okay, 2 power n into n factorial square divided by. Okay, you can use the reduction formula and then you can prove this one. 2n plus 1 factorial is going to come. Okay, for this one. Now you have already this one. Okay, so therefore this is going to become like 1 by 2 power n into n factorial into 2 power n. So this is going to be square 2 power n factorial into 2 into 2 power n into n factorial whole square divided by 2 power n plus 1 factorial is there. Okay, so these two gets cancelled. Okay, then I have 2n factorial is there, 2n plus 1 factorial is there. Therefore this is going to become like 2 by 2n plus 1. Okay, so that's what we have proved. Thank you.